Okay, in this video, I'm going to talk about some basic SolidWorks drawings, like draw a simple shape and also do a simulation static and dynamics. Okay, so first of all, have a model. It could be very simple, so do a part. Right here, we have some sketches. So like this one, we will draw a base first. It's a round base. So I click the circle. Click the circle, select the face that you want to have the top plane. Usually it's the ground plane. So after you have the circle, it is means that it is not defined. So define it. So right here we make it to be 1 meter, 1000. Okay, after we have the circle, we need to we have force. Make it a 10 centimeter height, 100 meter. Okay, now we have a disc, and then we need to have some other shapes like a pipe. So it's also a circle, or if you want to make it like a rectangle, you can use a rectangle. Select the face that you want to. Okay. So there are a lot of kind of rectangle to or use the word rectangle. Want to also we need to find it, so we are dimension find it. Example 10 by 10. Okay, have the sketch another time. You can see how high it is. So you make it 1.5 meter height. Okay, so what if you want to cut a hole on it? So it's not very, doesn't have to be. You can draw on the plane. But normally we will want to normal to the surface that we are drawing. Can use here like find the thing that we are drawing. There are some other sketch like a line, draw a line. There are some circle, arc, polygon. Of course, the line and circle and the rectangle is the most popular use. So there also center line, which that this line is in dashes. So this line will not be taken into consideration. Then we want to drill hole. Make it like 5 millimeter. So you 5 millimeter. So it's still because we didn't define the distance to the top. Will be black until it. So then we it's not extrude this time. It's extrude cut. Cut it. You can define how long it will be cut. It's long, or we can just select through all. Cut through all the things that you can. Now we have a hole. The part somewhere is here. So this is a part. Then what if we assembly? Right, so we assembly. Assembly is a lot of part in a file, so they can have parts. But assembly component. So the base that we just draw, and for dynamic simulation, I need another fist punch it. So I will put a fist box to make it. Can make it, but simpler for simulation because many triangles complicated. It's hard for the So here we have some, after we insert the part, mate them. So here we have coincident. Can put point to become incident, to edge, then up to you. Parallel is uh, it's parallel. You can put plane or two lines to be parallel. Perpendicular, tangent, and are very commonly used. There are some advanced mate like symmetry or mechanical like slots, cam, hinge, but I guess it's not very popular. We have coincident. You can put this and coincident. So as you can see here, well, your freedom. They're totally six degrees of freedom are fixed. Now you see I can still drag it, rotate it, but I can only rotate in one direction because the other two are fixed. So only direction. Another mate. Make this now. I can only launch the object in start in a place that is not contact or away. The component action stop at and drag it, stop when touch it. Actually, it's not actually touched, very close, but it's fine for. And you save the file. Copy this later. Back to this art. Usually there's a static simulation. It can be very quick, but I guess it's not very close to because you want the punching situation. But I'm still going to talk about it. So static. So in the SolidWorks add-ins, have simulation. You need to click it in order to have this tab simulation for study. Here is the static. Another one is the nonlinear dynamic. This is the tool that we are going. So in the static, we study must have the material here. Yes, and also apply the material. I choose ABS because body is normally to and also ABS is close to. You can also apply other material. There are a lot of material that you can use. Must has the density. Must has the tensile strength, and some of them is important. Like for example, if you glass fiber, a lot of values are missing, so you can. So here we use yes, it's shown here. Connections. Here we only have one part, so it does not have any connection with others. Fixtures, you have some fixtures here. You can see fixed geometry will fix the degree of freedom. Roller will fix some of them. Hinges, it will only allow the rotation in one X. Other things like elastic or bearing, they're not. Hence, there are also some advanced fixtures that we might use later, like reference to flat surfaces. But here we will fix this point, fix the button. So we say that this platform is mounted on firmly, it will not move and not deform any surface. We have some external loads like force or torque, pressure, gravity. Some of them, we will apply a force. Like say here, so you punch it. And typically it's 1000 Newton. Actually for a boxer they can have more, but you can assume this. We have this, now you can see the arrow is fixture, the purple is a force. The mesh, you can create them manually. Like here, you can decide how fine you want them. Here, normal of triangle. Then finally, there are some options, properties. You can use the default. They have problem, you can adapt them, like later use the large problem X parse, so it will take into account in the that is a big displacement. Adaptive, you can use a H adaptive or adaptive, but you can use not. So we run it here also. Static can be, you can see the excessive displacement. One suggests you to use large displacement, so static can be really close to your expectation, right? If you're probably the like this is the stress, so you can see here highest stress chat option. Usually we want to have some settings like here we want to show the max attention, so we know which place has the highest stress. And you can also make it create boundary mesh, so you can see your mesh reaches. Okay, that's the stress point. Strain point not properly. Placement is important. You want to know how much is you can see moving in a distance. Chat option. You can see here says that the red is around 100 millimeters. So normally the default setting is not case. So you see here automatically define the minimum. Oh yeah, deformed shape. So right now it's in true scale because form a lot. Most situations, if the deformation is small, SolidWorks will use automatic. So well exaggerate, make you see it clearly how big it is. But it's not. You can use true scale, but normally it's true settings. You can put a transparent color on it. Or I use 0.5 meter. Change it back. Yeah, use true scale. Okay, so here you can see this is the original position. The move, but you see static means that you put the fist at 1000 Newton force on the top of this bar for a long time, and it will become like this. And when you take out your fist, it will not change it back because it's elastic formation, so it's not very real. You can also make an animation, animate it. Probably you can see like this. Okay, so what about the dynamic? Dynamic is very time consuming. So I won't actually it's first time that I use it. There are a lot of problems, so it's not very realistic. I think very like to expect this launch it, you jump up a little and then settle it down somehow. But that is, in my opinion, kind of hard or nearly impossible. At least I don't know how to achieve. So because I put a mate here, that's what I did. So they have a component context. Also, I need to have a context set. So can you a context set here, which is two part. So later when you count it, it's saying one contact. So get a set to be no penetration, cannot get penetrated. And add a little doesn't really Okay, so I need to there's an initial condition. I set it add the initial set it to be this part, this whole part. You select this whole part from the. I select this edge. It's the direction. So I set a velocity initial velocity at -9 because okay, 9 I think 9 or minus. Yeah, if you set it to 9, you can see the arrow is to right, but we want it to flat, so we put negative -9, which means that search so a punch will be at this speed to something. But of course, this punch may be too lightweight because I set it to a alloy. You find the proper mass. You can find the mass and evaluate. Pick the part you want to evaluate. Mass property. You can see the mass, 1 kilogram. The volume, surface area, or other things. Initially, it doesn't. Okay. So I have the reference. Mm, it's another kind of fixture. So here I use reference geometry. I click the vertex. I click the face, which is this face and vertex. Then there are 3 directions. You get 4 arrows, which means that allow it direction certain amount. So you put 0 means that you doesn't allow it to move direction. Also 0 here, which means it only move in this direction, which is along the line of punching. Right. So a roller slider. I put a roller slider at here, which means that this part can slide on the ground, which is not true. Actually, that's the part that I haven't figured. I haven't figured out because what you want to say, what you want to have is the virtual ground. So part is lying on the ground, cannot go below the ground, but it can move above the ground. But normally, if you set it like that in SolidWorks, it will says that will say that your part is not fully defined or it's too because software may not cannot solve it. And then you add a gravity here, which is normal, 9.8 downward. Actually, I think I want to try. Maybe like I try to make it on the ground. I haven't tried this. So again, you the triangle for a very big. Uh, 90 is too probably too. I draw. I extrude it. I use some shortcuts. So, but you already know how to use strong. Make a strong floor. Save it somewhere. Go back to the assembly. I'm going to search the ground. I'm going to fix the ground. Those on unfix. Fold this part. So now this can move free. So again, you move. Sorry, collision detection. Post collision contact. Yeah, at the middle. Okay, okay, done. Let's go back to the net here. Right, so right now we have some new constraint. I need to remove roller. To add a fixed geometry. So we fix the ground. Yeah, I hope that will work. The mesh is shows a angle because we change it, so you need to mesh it. But if you click wrong, it will mesh it anyway. Oh, damping, yeah. You can have some damping. You can put a number here. It's hard to be real. Search for the parameters, but so I put some fake numbers. Want to be accurate, close to the mass matrix and the stiffness characteristics. So we run, but this is very time consuming. So first you will mesh the part. I will put it for this process for a while. Can jump to the later when or maybe probably I will start in the middle because you can get some sound at the beginning. Because uh punch is not also not very real. Because there are ABS and alloy. Still, the alloy they will contact very quickly and then get away. But in real, the punching contact time is much longer than this. So you probably need to find some material, for example, rubber that can be closer to the characteristic of a human punch. Okay, so I'm going to cancel it here. I think you have some 3 time steps, so you can probably see some results. But it's very time consuming. So as I said, you want to make that simple. Get some stress here. It should be here, right? As we previously see for moving down uh process. So we want to have the chat option. So here we can see that mesh pose and also. Yeah, so we can set 3.6 0.36 millimeter, but it's 3 time steps and 3 time steps as setting. You can set here probably 1 time step is 0.66 seconds. It's very small. Okay, so face is not moving. Maybe if you simulate long enough, you can see it. I'm not sure. We can also animate the result, but uh we only have 3 time steps. So we can right time time here. So it only has 2 frames, actually 1 and 2. Cannot see much thing. Probably if you play long enough, but I should say that it's very time consuming. Find a better way, like it. Also probably like this ground to be right. You can make a very small ground. Doesn't have to make a run. Yeah, yes, that's all. You can figure out by searching some video, but very cool and you very hard to be